Hello and welcome to a set of 3 examples on solving equations with fractions in them. So you do need to remember some of your basic fraction work with numbers to help us solve these equations. The first thing that we're going to do here is to collect the expressions on the left-hand side of this equation into a single expression, and we'll do that by finding a common denominator. Now, the lowest common multiple of 3 and 7, our denominators here, is 21. So we want to turn both fractions into fractions over 21. And to do that, we'll have to multiply the numerator of that first fraction by 7. And, of course, multiply the denominator by 7. So multiplying the top and bottom of that fraction by 7. Similarly, to create a common denominator, to get a denominator of 21 on this second fraction, we'll need to multiply the numerator by 3. 3 sevens are 21, and our numerator also multiplied by 3. So all of that's still equal to 5. We haven't changed the value. Here we've just changed the way this expression looks. So now we can write it as a single fraction, and the way to do that is just to combine it together. So 7 lots of 2x plus 1 plus 3 lots of 3x plus 2. All of that is now over 21, and all of that is still equal to 5. Now we can multiply both sides by 21, and at the same time I'm going to expand out the brackets on that numerator. So the numerator becomes 14x plus 7 plus 9x plus 6, so that's expanding out the numerator, and the right hand side of the equation is 5 lots of 21, which is 105. Now we want to simplify the left hand side of the equation. 14 plus 9 gives us 23x plus the 7 and the 6 add together to create 13. All of that's still equal to 105. Subtract the 13 from both sides, and that gives us 92. And finally, divide both sides by 23. Now you might think, oh no, I don't want to divide by 23, but in this case, if you think about adding 23s successively, it only takes 4 of them until you get to 92. So 4 23s are 92, and in this case, x is equal to 4. Now, in example 7b, we've got a similar looking equation. We're going to again create a common denominator, this time of 55. So to do that, multiply the first expression in this equation by 11. So that's the numerator and denominator of that first part of the equation multiplied by 11. Then the numerator and denominator of the second part multiplies by 5. And all of that is still equal to 1. Now we can combine this into a single fraction. So we've got 11 lots of 3x minus 3 minus 5 lots of 4x minus 2. And the difficulty in this equation is all the negatives. So all of that's over a single common denominator of 55, still equal to 1. So as we did in the last example, I'm going to multiply both sides by 55, and at the same time, expand out the brackets on the numerator. That gives us 33x minus 33 minus 20x, and then this is the important point to notice, the negative 5 and the negative 2 multiply to make a positive 10, and all of that is now equal to 55. I've multiplied both sides of that equation by 55. Combining the terms together, simplifying the terms, gives us 13x minus 23 is all equal to 55, and we're nearly finished. Adding 23 to both sides gives us 13x is equal to 78, and then dividing both sides by 13. Again, you might think I don't want to divide by 13, but if you add successive 13s together, you'll quickly see that 6 of them make 78. So x in this case is 6. Now just one more equation of this style to do, slightly different looking one here, and where we have a fraction on either side of the equal sign. And to get rid of the denominators here, what we want to do is multiply by 3 to get rid of the denominator of 3, but also multiply by 5 to get rid of the denominator by 5. So actually what we're doing is an overall multiplication of 15 on both sides of this equation, but some people call this method cross-multiplying, and what we end up with is 5 lots of the expression on the numerator being equal to 3 lots of the expression on the numerator on the other side of the equal sign. So you can maybe see it looks a little bit as if that 3 has gone across and multiplied by that 4, and that 5 going across and multiplying up there. So some people call this cross-multiplying, but essentially we have multiplied both sides of this equation by 15. Now, you've probably seen equations like this before. Expand out the bracket on both sides, and then just start to collect up and simplify. So subtracting 12, x from both sides gives us 28x. And then adding 5 on gives us 28x is equal to 14. Now don't fall into the trap here. We must divide by 28 to solve this. 14 divided by 28 is equal to a half.